Okay, so firstly the converse, you just swap them. So if P implies Q, then Q implies P. So write the converse. If N has exactly 2 factors, then N is prime. Okay, that's done. The contrapositive is not Q implies not P. So if N does not have exactly 2 factors, then N is not prime. And if the contrapositive is true, then that means that the original statement will be true. So determine whether or not the statement is equivalent. So the statement would be equivalent if P implies Q and Q implies P. So is that true? If N is prime, then how many factors? It has exactly 2 factors. That's actually true. Okay, and then if you did it the other way, if N has exactly 2 factors, and the only 2 factors it could have would be 1 in itself, because every number has 1 in itself plus other factors, then yeah, N is prime, so that's true. So therefore, the statement is equivalent. Okay, so part 4. George says, if N does not have exactly 2 factors, then N is composite. Determine whether or not this statement is true, and if not, give a counterexample. So if N doesn't have 2 factors and it is composite, a counterexample would be 1. So it's not true because there is actually a counterexample. Okay. Now N is part of the natural numbers. That's like the counting numbers. Write the negation of this statement. All meerkats eat grubs. So you change the all for there exists a meerkat. There exists a meerkat that, so you keep the original statement, a meerkat that does not eat grubs. Okay, this is different negation of a statement compared to just negate this, like how it had the other.